Good morning, everyone. Thank you for joining our session, Building Your MLOps Strategy for Generative AI. A pretty light, not so dense topic for a Wednesday morning, I'm sure. My name is Mikhail, an outbound product manager on Vertex AI, and later on stage, I'll be joined by Irina, our product manager of our Vertex AI evaluation services. Before we jump into our content, I want to run a quick poll. Number one, if you could raise your hand if you or someone on your team has actually built a really exciting, compelling demo with generative AI in the last few months. A lot of folks, more than half the room, and I think we've really seen the pace of hackathons and working prototypes really increase over the last few months. Number two, how many of you have taken said demo into production? A lot less, a lot less. And number three, last question, I promise. How many of you have really spent the last few years designing, thinking about, and maybe rolling out an MLOps strategy before generative AI? Okay, good amount, good amount. So I think we're gonna really tackle these questions and really address two key themes. Number one, and based on this quick poll, building is easy, deploying them into an enterprise-ready production environment is really, really hard. And this quote from Chip, I think a lot of us really feel the same way. Second is really, isn't it funny? A lot of you raised your hands for that last question. Right as we were getting a hang of MLOps, I personally have my professional ML engineering certification proudly in my LinkedIn profile. Right as we were getting a hang of this, now we're really introduced to a brand new mountain of terms across LLM ops, Gen AI ops, things like vector databases, prompt engineering. So really, we'll touch on the best practices and really believe that you do not have to start from scratch. So what's our agenda for today? We'll quickly revisit MLOps from the last few years. We'll share an evolving framework. I highlight evolving. We are very early in this space. And I'm excited to have Irina come on stage and share some of our new evaluation services, launching specifically for generative AI use cases. And then we'll end with a recap. So first, let's quickly start by revisiting MLOps from a few years ago. And we'll actually start with a direct quote from our Practitioner's Guide to MLOps paper from early 2021. MLOps is a set of standardized processes and capabilities for building, deploying, and operationalizing ML systems rapidly and reliably. Throughout this paper, there are a number of concepts highlighted: shorter development cycles to accelerate time to market, standard governance processes to manage and monitor models, and really increase reliability, performance, and scalability. From a first glance, really our hypothesis is that the objective of MLOps for generative AI should remain very similar, if not the same. And fun fact, two of the authors of this paper, Don and Eric, are actually here somewhere, so see if you can find them and maybe pick their brains a little bit more for the remainder of the conference. So from that starting point, we really do believe that you can start by building on existing MLOps foundations. And there's really two big ideas. Number one, no need to throw away your existing MLOps investments. There is a path to extend MLOps foundations from yesterday's AI, what we're gonna refer to today as predictive AI, to today's generative AI. A lot of the core concepts we really feel have a lot of similar characteristics: managing and evaluating models, orchestrating pipelines, evaluating and monitoring models in a systematic way. However, I don't think we need to acknowledge that generative AI does introduce a lot of unique properties and characteristics that we need to really rethink and really upgrade our MLOps strategy. Large pre-trained models, pre-trained multitask with increasing AI infrastructure needs. New ways to customize models, not just training, but tuning, customizing those models. Evaluating and monitoring not a single prediction, but huge chunks of generated output, images, chat logs, and really connecting these models to fresh and relevant data from other systems. So throughout this talk, we're gonna go through each of these 5 bullets on the right side and showcase some ideas around this and how we have services available today on Vertex AI platform and Google Cloud. And by the end of this talk, we will demonstrate that you don't need to learn a whole new discipline or build a whole new platform. We don't think you need to have a completely separate, standalone generative AI MLOps stack. Really, MLOps on Vertex AI is the same platform upgraded to support both predictive and generative AI capabilities. So like a lot of you who raised your hand on the last question, whether you're developing, deploying models around regression, classification, object detection, forecasting, or looking into new use cases around code and text generation, summarization, chat Q&A, really do believe that you can use the same platform to manage that AI lifecycle. So now let's move to really bridging the gap from yesterday's MLOps to today's MLOps for generative AI. And let's hopefully start with ideally a not so controversial diagram. A lot of you probably have many different versions of this within your organization. We have the two big phases, training and serving. Training generally has an experimentation phase and then really operationalizing the training step. Serving usually includes deploying a model to an endpoint and then getting predictions through an inference pipeline. Throughout the last few years, along the top, we've learned that we need to evaluate and monitor these models throughout all these phases as the world continues to change and is very dynamic. And throughout the bottom, we've really converged as an industry on how to log various artifacts, models and model registries, features and feature stores, maybe pipeline DAGs in a template gallery. So now what we're going to actually do is we're going to extend this framework and we're going to highlight what we're layering on top of this. And to make this easier to follow for the next 15 or so minutes, we're going to layer on in blue some of the unique nuances that you need to think about with generative AI, and then also highlight some of the capabilities that were announced yesterday or available for the last few months on our platform. So first thing we're going to do is we're actually going to gray out some boxes, and we're going to add discover to the experiment box, and we're going to add prompt to the predict box. In the past, experimentation likely meant you were exploring data, you were running different training jobs and hyperparameters. You're really focused on a very specialized task. Well, today the first step is very different. It's more around discovering and finding a lot of different pre-trained models that are able to tackle many different tasks and figuring out which model is right for your task, and you can really get a very quick head start. The second thing you'll notice is that there's a shortcut directly from discovering and experimenting all the way to the model to be able to run predictions. The only thing you need to provide are a set of natural language predictions or prompts. And this is really the reason why a lot of folks raise their hand in the first question. This has really lowered the barrier to entry to AI and really a catalyst for a lot of these excitements. So first, quickly, how do we handle this in Vertex AI? Over the last few months and yesterday, you've heard a lot about Vertex Model Garden and Vertex Generative AI Studio. Quick primers on this. Model Garden, your discovery portal, your entry portal to a lot of different models, whether they be Google models, open source models, third-party models, to really get started and understand which models may be a fit for your use case without having to really start from collecting a lot of your data and labeling millions of data examples. And whether you're using one of our fully managed APIs, an open source model, or really a fully custom-built model architecture, a lot of this is powered by really strong purpose-built AI infrastructure with GPUs and TPUs. Now, what's really intriguing to me is, I know it's really small on the right side, but all these tiles, there's about 20 of them on this page, all these tiles today are actually in our prompt gallery. Tiles around use cases like classification, entity extraction, summarization. Just last year, if you probably would have asked me, how do I get these types of capabilities into my applications, into my business processes, I would probably have a separate ML pipeline, a separate labeled data set for every single one of these. And now they happen to work magically out of the box with simple text instructions. So this is kind of the first intriguing part of why we're all excited. However, we all know that things are not as simple as they seem and not as easy as we always would like. So in the next iteration, we actually bring back the training and serving boxes, and we introduce a few new terms in blue: customize, tune, distill. And I think that the idea here is you don't train these models necessarily in the traditional sense, the hundreds of thousands of labels, the millions of examples. In this case, you're rather customizing or tuning them for your specialized tasks. And tuning these models, we also added a curated data box in the very bottom in blue. Tuning these models will likely not require the same input pipelines or features of the past. You'll really need to rethink your existing data lake and data warehouse strategy, really purpose-built for these new types of AI models. And let's dig into this a little bit by talking about some specific examples. So you can get very far with prompt engineering, but whether you're looking to further boost the performance or optimize the cost and latency of these models, we really do believe that tuning will become very common across most workflows. And yes, that image was generated by Vertex AI Imagine, of a dog that's been tirelessly prompting for the last few days, weeks, and then has to probably now think about tuning the model. So first we start with supervised tuning. This is really suited for tasks with a standard answer, which can be proven or justified fairly easily. And within Vertex AI, this is enabled through a simple JSON-L file with 2 columns, a lot of input and output examples that you curate for your specific task. And tuning is now available for text, chat, code, as well as image. But for some tasks, it's not easy to define the expected output, especially for summarization and chat use cases. You can't always articulate what makes one response better than the other. However, this is high fluency is still one of the key values of these larger models. So RLHF, or reinforcement learning with human feedback, is really useful for these tasks by really adding preferences amongst options to update these models. And yesterday, again, we launched RLHF in public preview for both our Google PaLM models as well as open source models like Llama 2. And then finally, data curation at the bottom. I think we all start with these pre-trained models. We may not know what data was used for them by various different organizations, but now we really need to add to that. And this is where we double-click into what do we mean by data curation. This might mean augmenting really generic pre-training data sets with data sets that are specific to your domain. This might mean really adding in different task mixtures that you want the model to really understand, or highly curated data examples for a specific task. And I think this is actually a great opportunity for a lot of our partners. I met a lot of folks from the Snorkel AI team yesterday. They have a data-centric AI platform with programmatic data labeling, data curation, and data management to really accelerate AI development, especially once we move from prompt engineering to the new phase of tuning as well. Now we move on to governing additional artifacts. I just have a little blue box around the govern data and artifacts box, and we have now new artifacts. Tuning pipelines, adapter layers, embeddings, but how can we leverage existing best practices that many of us are familiar with? And I would say this is probably one of my favorite topics because this is the one I truly believe we don't need to recreate the wheel. And I was demoing this at the demo booth with a lot of folks, and these are capabilities that exist today on our platform. So when you start, and we really think that a lot of existing tools and best practices do apply. So when tuning, when we get into tuning these models with pipelines, you really want strong reproducibility, lineage tracking, and metadata management. Sounds very similar to our existing pipelines, whether you're using Spark, XGBoost, TensorFlow, PyTorch, and really tracking all your experiments and all the artifacts throughout that. So when you tune models on Vertex AI for foundation models, this is all orchestrated by Vertex AI pipelines alongside your existing predictive AI pipelines. Once you get a hang of tuning, you need to start managing these tuned models. Many tuning techniques that we leverage today use what we call adapter tuning. They only update a small set of weights within those models. And managing these adapter layers alongside your existing models, they may be pickle files, sklearn files, your TensorFlow save model files. It is a clear win in model management to use existing model registry capabilities. And with our adapter tuning service, these adapter layers are actually only tens of megabytes in file and then get passed to our foundation model alongside your prompts to generate an inference. Again, this is something that's available today. I was demoing it to many of you yesterday. Come take a look as well if you want to learn more about that. And then finally, embeddings. I think embeddings, you probably heard embeddings across a lot of sessions over the last day and a half. They are really one of the most powerful and magical tools to really extend LLMs even further. They take unstructured text, images, videos, and really create a vector representation of them to be able to do use cases like search and recommendations and similarity matching. Well, why not store these embeddings alongside all your features? So we actually are introducing embeddings as a feature type within Vertex's feature store. So hopefully you're getting a sense of, again, especially for artifact management, really build on a lot of the capabilities and tooling that you're familiar with today and just extend them for the needs of MLOps for generative AI. Now, don't worry, I did not forget about prompts. I mentioned prompts in the beginning, but we do know that prompts are probably a very new artifact type. Some folks are maybe using Git. They're using maybe newer tools that are out there. And Vertex AI does come with a prompt gallery. It comes with a way to share prompts across team members, but we're really excited to partner with really strong innovators in this space. In this case, we're excited to partner with Weights and Biases that actually has an integration with the Vertex AI Palm to really manage and analyze your prompts. Pairing Weights and Biases, which is really, over the last few years known for their experiment tracking, their artifact tracking capabilities, we're able to log and analyze the inputs and parameters of Vertex Palm prompts. You're able to better understand and debug your LLMs as it goes through the different inputs, outputs, and this is a really great way to support evaluation workflows. I want to give kind of a big shout out to Thomas from the Weights and Bias team. He published a report yesterday for us that is available live today on that link. You can probably Google Weights and Biases Vertex Palm. That actually walks you through a lot of examples. On the top right, we have a screenshot of logging a lot of the parameters, inputs, outputs of Vertex Palm directly into Weights and Biases, and my favorite example is actually in the bottom right, where we actually have a Vertex Palm LangChain integration, logging the flow of data into Weights and Biases to be able using the agent integration. So being able to really understand when you get into slightly more complex multi-chain agent use cases, what is a nice way to visualize it and really troubleshoot and understand how those input and output prompts are flowing from one place to the other. So we're really excited about that as well from a prompt management perspective. Next, we want to think about the top layer. Again, evaluation and monitoring. Very important, but a new set of metrics and challenges for certain use cases. So, most of us love highly quantitative, very clear metrics. Mean square error, precision, recall, accuracy. But how the heck do we evaluate and monitor, again, large chunks of text? Maybe one part of that text has a number that's very important. What is the right target objective of your use case? Is it accuracy? Is it fluency for chat use cases? Is it factuality for automated business decision making? If it's externally facing, what is the brand and reputation risk? Irina is going to come on stage and really double click into this. And this really has, talking to a lot of internal teams and enterprises, evaluation is really one of the top challenges, if not the most challenging part today. Two is capabilities on the monitoring side. This is also a fast evolving space. What we want to highlight are two capabilities that are available today. One thing is safety scores. So anytime you provide an input, get an output, a lot of times you may actually delegate providing the input to external or internal users. You want to really have comfort in understanding what type of content is being inputted or generated out. And within Vertex Palm, for every input and output request, you actually get an automatic payload with safety scores across 10+ categories that then you can rely on to monitor and set appropriate thresholds for your use cases. And third is recitation checking. A lot of us, maybe top of mind is, what if the output of this model is using someone else's original content? So we have built-in recitation checkers that actually scan the output of the model and then assess it versus existing code repos, existing web articles, and if there's a large enough chunk that matches exactly, we either block it if it's very large, or if it's within a certain threshold of text characters, we actually provide a recitation in the output of the API call. So again, different things that we're not used to from a model monitoring space. This is very different than the traditional things around training and serving skew, or tracking feature and prediction drift. Very different ways to really, again, augment your model monitoring strategy. The last part, I think that we introduce in the blue is, again, the last phase about connecting to enterprise data. I think these foundation models are still frozen in time, stranded on an island. I think what we're really excited about is really that the big opportunity maybe lies in retrieving data outside of the ones that existed directly in the model itself during its pre-training phase, as well as enabling certain actions. And once you connect them to more data, that makes evaluation and monitoring even more challenging. So this, again, the horizontal boxes actually stretch across this and probably add additional complexity to that. And for this one, I'm going to touch on this very lightly. There's a lot of great sessions here. We'll touch on it on the last slide. But to start exploring this new approach, I want to really touch on three concepts and patterns. One is probably the fastly adopted common pattern to process your data through embeddings, store them in a vector database, and query and analyze them with your large language model. Could be a base model, it could be a tuned model that you put in some effort into improving as well. Now, we want to highlight that Vertex has three core services. One, we now have a suite of embeddings across text and image. Now you can actually project both text and images to the same vector space to really be able to compare the semantic knowledge within those. We have various options to store these embeddings and retrieve them. We have both a Vertex vector search as well as Vertex feature store with new support for embeddings alongside your existing ML features. And of course, various options from Vertex POM to open source at third-party partners. Second is really looking at built-in grounding capabilities. Really the ability to generate responses based on your own data, providing citations to really give you some risk mitigation around, again, everyone's favorite topic, around hallucinations. And here we have a joint solution, both integrated into Vertex POM and leveraged by Vertex Search, which you're able to actually do grounding on your own enterprise data. And third, yesterday, if folks attended that session, we did launch Vertex extensions with the ability to author, access, and manage extensions to really connect to real-time data and to real-world actions. So these are some of the various concepts and capabilities to look into when you're really, again, extending generative AI to connect to enterprise data. So as you can see, we've really taken you through a journey, how to build on an existing framework that hopefully was not too controversial and really extend it to support both predictive and generative AI. I think this diagram actually, for folks who maybe were keeping tabs of our launch blogs yesterday, you'll see a double click into this diagram and some of the specific launches that you can map to each one of these sections. So, we've introduced a framework. Of course, we've shared some product capabilities. But what are some of our partners and customers doing? So one of our favorite partners, Datatonic, I got to meet them last year, based out of London. They're a data and AI technology services company, really helping clients bringing AI models and systems into production. And they've really applied, again, their existing expertise with MLOps and Vertex AI for the new needs of LLMs. And they've been working with a gaming company, social gaming company in Sweden called Hyber, to really bring Gen AI-powered game creation into production. And I really love the approach they shared with us on the right side. If you notice, for those who have maybe keeping up with research papers the last few years, the diagram on the right side is a view very similar to the 2015 paper, Hidden Technical Debt in Machine Learning Systems, where the LLM box, it is core, but it is very small, a small fraction of really the broader system. You know, the required surrounding system to really actually get this into production, maintain it, monitor it, is just as important. And they really highlight some key extensions to MLOps, including guardrails, vector databases, human feedback, and maybe UX, user experience changes that are needed to really create that data curation pipeline, as well as prompt registries. Luckily, we actually have a lot of the folks here today, and they'll actually be presenting with Hybrid tomorrow for creating the gaming metaverse with hybrid, datatonic, and generative AI. And again, we're excited to really see how many of the early adopters, many partners and customers are taking generative AI into production. So I think wrapping this up, I think I'm going to hand it over to Irina to really go into what we again believe is probably one of the most challenging parts of bringing Gen AI to production, and that's the evaluation process. All right.
Thank you. Thanks everyone for being here this morning. My name is Irina, and I'm excited to announce our new Gen AI evaluation service. This service helps you make decisions. It helps you understand if all of the exciting Gen AI announcements that you learned about during this conference actually solve your problems. Evaluation is key along the entire MLOps lifecycle, especially when it comes to Gen AI though. Because think about it, the very first step in your development workflow is to pick the right pre-trained model to work with. And to make that decision, you need data. So that data is an evaluation result. At the same time, the generation of new contents is just notoriously difficult to evaluate. Let's look at this example. For all of you, I think it's easy to spot a bad summary. It might be wrong, it's too long, it lacks structure. But what about outputs B and C? Those are two good summaries. If I ask each and every one of you, you might have a preference. But it will get difficult when I start to ask you about telling me the specific reasons why you chose one output over the other. And when you ask your neighbor, they're going to have a different preference. So there is no clear winner here. What makes it so difficult to evaluate these generative outputs? We identify 3 reasons. First, there is a lack of data. In predictive ML, we all started by curating a sufficiently large data set. We kicked off every project with building this data set, then we have our train, test, validation split, and that's all you need for evaluation. Now, with these generative models, the beauty of that is that you can actually get started with next to no data, because they are few and zero-shot learners. But the downside of that same coin is that you don't have the data to show what a good output looks like. The second issue we face is that it's not easy to evaluate these models by only looking at metrics. Right? Think about the summary. There is no one clear metric that describes how a good summary should look like, how a good news article should look like, or how a good painting should look like. If we think about it, if we think about the summary example, we can all agree on a set of proxies. No longer than 50 words, truthful and concise. But these preferences, these proxies, will differ person by person. So preferences come into play when we talk about Gen AI evaluation. And ultimately, and you've all seen this throughout this conference, the decision space suddenly becomes very large. And I want to double click on that. So I just talked about it. You start by picking a pre-trained model to work with. For this, you need to understand performance, and you need to understand efficiency. You need to understand cost. Then there's a number of tuning options to work with. Then you might want to evaluate if you can distill the model to get a better cost-performance trade-off. And then ultimately, evaluation does not end with performance. You need to understand if your model is trustworthy to really put it in front of your customers. What we offer you today to solve this challenge are the initial building blocks of our Gen AI evaluation service. You can choose different evaluation targets, 2 evaluation methods, and access a number of metrics. And so if there's one thing you're taking away from my talk today, it's this slide, please. We're launching 3 services today. First, Autometrics. This service, it gives you a number. And this number is indicating if your model is doing a good job on a specific task or not. Second, auto side-by-side. This service helps you choose between two models. It helps you pick which one does best in solving your problem. And as I said, evaluation does not end with performance. There's also a trust element to this, which is why we launched safety bias. This service helps you understand if your safety filters are robust. And now I'm going to discuss each of these services in a bit more depth. Let's start with autometrics. I think this is most similar to how we evaluate predictive models. It's a set of metrics. It allows you to quickly and efficiently evaluate model performance. This is the standard method we see in academia and industry benchmarking. And for this to work, you need to provide us with the model that you're looking to evaluate and a reference data set. And we provide a pipeline that outputs a metric, a number between 0 and 1, that tells you if your model is performing good on a set of proxies. Here's how this looks like. So while this is coming up, you can have a look at the slide. No? OK, it's already here. So we have this is the Vertex AI pipeline view that some of you are familiar with. We have our model. You provide us with a reference data set. This reference data set is ultimately a set of prompts and the ideal output. What happens, and this is why it's not live, it's taking a bit of time here, it took 14 minutes. We now run the model predictions to get the new model output. We compare this new model output to the ideal output that you provided in your reference data set. We compute a metric. Well, and this is it. For us to choose the right metric, you need to specify which task you're focusing on. So in that case, let me scroll down a bit. It's a summarization task. There you go. And for summarization, the appropriate set of metrics is the Rouge family. What this set of metrics does is, in a nutshell, measuring the degree of overlap between this reference text that you provided us with and the new generated contents. And because I'm dealing with a situation here in my task that has multiple sentences, I'm choosing Rouge LSUM. So here I see Rouge LSUM is at 0.12. This model is performing really poorly on a summarization task. All right, let's go back to the slides. While we go back to the slides, you can keep. OK, here it is. Next slide, please. OK, so metrics are important, as you need something that's quick and efficient and that helps you guide model development. Let's think about Rouge LSUM. If there is no overlap between the text you provided us with and the new text that's generated, there is something wrong with this model. But how to capture the nuances of a generative task? How to get closer to human eval? Today, I'm really, really excited to introduce auto side-by-side. This is one of the most advanced evaluation capabilities. This method is first of a kind. It's built by Google Research. It's how our internal teams evaluate model performance. This service is comparable to human evaluation, but it's faster, and it's available on demand. What happens here in a nutshell is that auto side-by-side allows you to A/B test your LLM. You provide us input prompts. And auto side-by-side then compares the performance of two models against each other. And it's doing that by using a third model that we call the arbiter. So we have a situation where it's LLM against LLM, and there's a third LLM that's judging the outputs. Let's, again, have a look at how this looks like. All right, I'm back in this pipeline view. There's a lot going on here. But basically, on the left side, you see everything around model A. So model A in its prediction results. This is the model I've been tuning and playing around with. And then there's model B. Same story, model B and the prediction results, but this is the pre-trained model that I've started with. And the exciting thing is down here, that's the auto side-by-side arbiter. And again, this takes a while, so this I already ran. And the output that you see down here in the right-hand corner is a win rate. So what is a win rate? The win rate tells me, is model A or model B winning? And in that case, the judgment is very clear. Model A is winning in 93% of all of the cases that the judge saw. So model A is the clear winner. Now, it's difficult to trust this arbiter model, right? Because it's running through all of the cases, it produces a number. But then summarization is such a nuanced task. How do I actually understand what the arbiter is doing? Here comes my very favorite feature of this service, is that this service is actually producing explanations along with the output. Let's have a closer look at how this works, and I'm going to zoom in a little because I'm aware that this is very difficult to read. But I'm going to read parts of it out loud, so don't worry. So I have a prompt here. We're again back at our summarization task, and the prompt is talking about a roommate who tries to choose a game to play. And it's talking about risk, and then specifies that, well, risk, but with no luck, something competitive, and goes on and on. And it seems that model A is doing a good job at summarizing this. It mentions the games that I saw in the prompt, and does this in a quite concise manner. And then there's something not working with model B. It tells us, make a list of the best games you can play, and repeats that a number of times, then comes a list. And the arbiter is agreeing with me here. It tells us that, yes, model A is the clear winner. But it also provides me the explanation for why it thinks that model A is the winner here. It tells me that response A provides a good summary of the context. It follows the instructions of summarizing in less than 64 words. Response B does not follow the instructions, right? It's not really a summary, and instead provides the list of word games. So this explanation helps you really interact with the arbiter and understand if this reflects your preferences or not. So this is why I'm very excited about auto side-by-side, but I'm specifically excited that we can give you auto side-by-side with the explanation bit. Back to the slides. So our job of evaluating models does not end here. It's not enough to test that your model is actually producing a good summary. You don't want to put something that's producing a good summary in front of your customers. You want to understand if this model, this summary, is trustworthy. Our safety evaluation bias service allows you to test the robustness of the safety filters. For this to work, you need to provide us with the model that you want to evaluate, and that's it. And what you get as an output is a table. It's showing safety filters overall. Mikhail already talked about these. And it's also showing safety filters sliced by identity group. And in this table, I picked the identity group gender, but there's other identity groups to choose from. So this service really tells me two things. One, is the safety profile of my tuned model worse than the safety profile of my pre-trained model? And two, is my model biased against a certain identity group? Is my model producing more toxic contents for, say, women against men? So after running the safety bias evaluation, I can look at this table. I can see if I have safety issues, if I have introduced a bias, and then I can take actions to mitigate that, like looking at my tuning data. All right, that was it for the Gen AI evaluation service. Thank you, and I hand it back to Mikhail.
bring it home. And I think as a tools guy that really was excited to actually see a lot of that run on Vertex pipelines. And I think that gave you a sneak peek into, again, using existing tooling, existing best practices, existing orchestration of pipelines, again, for generative AI tasks, including evaluation. So I'm going to kind of walk you through, again, some key closing thoughts around really building your MLOps strategy for generative AI. Number one, we really, again, talked about no need to throw away your existing MLOps investments and really learn from and build on your MLOps knowledge and investments from yesteryear. However, we actually walk through a journey of extending an existing framework, but augmenting it with the unique needs of generative AI. Prompting, tuning, new metrics and techniques for evaluation and monitoring, and again, new concepts like data curation and extending data to the enterprise world. Now, we really kind of kept this talk a little bit more focused on the MLOps technology, but one thing, again, just as important when really starting this strategy is also what are the use cases that you start with. And I think really our thoughts are around starting with very simple, single-step use cases that may likely have a very low-risk profile. Don't jump into multi-step, complex chains or complex agents that you're letting loose and really hitting on automated decision-making. Again, we really suggest that you start with use cases that don't immediately need high accuracy and have a risk profile. Maybe they have high fluency needs. They may have high creativity ideation objectives, and those are great ways to get started. I personally really like this framework that's out there publicly that looks at two axes around accuracy and fluency and really focused on the top left where a lot of the key advantages of generative AI with high fluency, but again, maybe accuracy is low to medium with again, human in the loop exceptions throughout that. Finally, we also wanted to highlight that our organization launched a tool for enterprises, partners, customers to quickly do a self-diagnostic on their AI maturity. This is actually building on our existing AI maturity assessment. It takes about 5 to 10 minutes. It's across 22 questions and gives recommendations and best practices on how to, across people, processes, and technology. This is live and available online today. We also have some cards that you can take home with you at the Vertex AI booth down in the AI Pavilion. The very last thing that we really want to highlight that today's topic was a little bit forward-looking, but not fully a forward-looking perspective. A lot of this is available today for you to try out on Google Cloud, specifically on Vertex AI platform. This is a sample architecture. In dark blue, again, the key components of discovering, experimenting, and deploying a model. So please take a look at Vertex Model Garden, Generative AI Studio, Colab Enterprise to really dive into a lot of open source code, like a lot of our open source models there. In light blue, the key MLOps capabilities that really surround that to allow you to govern this at scale for both predictive and generative AI. Again, Vertex pipelines, Vertex model registry, Vertex feature store, Vertex evaluation services are all there now to support both predictive and generative AI needs. And in green, newer tools for monitoring and connecting your models once they're deployed. And again, this includes the safety scores, the built-in recitation checkers, grounding on your enterprise data, as well as extensions. Some suggestions. We kind of laid out a map here. This was really meant as a broader, high-level framework. In the first column in gray were a lot of sessions that either happened yesterday or in the early 8 a.m. slot. These will all be available for you to watch on demand. But what can you do for the next later today and tomorrow? So on the last two columns, we've recommended, again, a few 100-level talks along the top that double-click into enterprise readiness common use cases for those who maybe want a little bit more of an industry use case spin on things. And then we've highlighted a few 200, 300-level sessions that double-click into our Vertex feature store, into prompt engineering, and announcing our new embeddings that now support multimodal image and text embeddings. I I will be around actually from 12 to 3 today at the Vertex AI booth in the AI innovation section. So please come say hi. We're happy to give you a demo of a lot of the concepts we've talked about today. And we also actually, for those of you who are hands-on keyboard, we really strongly suggest you go to the Innovators Hive led by our developer relations team, where you can actually go through a lot of code labs and really get some hands-on experience with a lot of these toolings. Like every other session, we really want your feedback. Any feedback is great feedback. So if you could log into the Google Next app, give us a score, let us know what we could improve. And we're excited to maybe share a lot more about MLOps for predictive and generative AI in the future through other channels, whether they be blogs or webinars. And we'd love to hear your stories. So please find us today and tomorrow. Share your stories, your best practices, your learnings, maybe some horror stories that you may want to share with us. So with that being said, thank you so much. And yeah, come find us and have a great rest of your conference.